We move into the sphere. So what is a sphere? A sphere is a three-dimensional solid figure which is made up of all points in the space which lie at a constant distance called the radius and the fixed point called the center of the sphere. Okay, so how to imagine a sphere? One practical way to do it and observe a sphere is to take a circular object like the bangle or a piece of coin. If you have a bangle or a piece of coin, you take it and try to spin it on the ground. Spin it means you make it go round and round. Now when you spin it a little faster, you will see the shape of a ball, which is the sphere. So you can see this diagram here. There is one bangle. Yes, the bangle is made to stand and you spin it with your hand. Make it rotate fast. When it is rotating, it will look like this, which is almost the shape of a sphere. Okay, so now you understood what a sphere is. If you can see the ball, the basketball, the football, volleyball, tennis ball, rubber ball, they are all spheres. Now the center of the ball lies inside the ball, in the interior of the ball. How will you find the center? If you take the knife and cut the ball exactly into two parts, one part will look at like a circle to you, and in the middle of the circle you will find the center. So if you take a ball or a smiley something and cut it exactly into two parts, then it will make what? Hemispheres, two halves. In the center of this hemisphere, the surface here lies the center of the ball. So when the ball was complete, then this would have been somewhere in the center. So now we are going to move to finding the CSA and the TSA of the sphere. Now mathematically it is very difficult to find the CSA, that is the curved surface area, and the total surface area of a sphere. How to find the area? Okay, so area is slightly mathematically will derive in the higher standards, but just now if you can do it practically, you can try it practically. How? You can see this figure here. To take a rubber ball, attach a pin to one side. Why the pin? To get a better grip. Now take a thread and starting from the pin, try to wind the thread against the whole ball. Wind the thread. Keep on winding slowly. It takes a lot of time and patience, but you have to wind the thread on the ball, tie it up. This whole thread without touching, without leaving any space. When you reach halfway, you can attach a pin again, turn the ball upside down and keep on winding it. So keep on winding the ball till you have filled up the whole ball with a piece of thread. That is a practical way. So you have wound up the whole ball with a piece of thread. Yes? Now, the ball that you have, yes, you can see outside it form a circle. It has got a radius. Radius. Now, take a piece of paper and draw four circles of the same radius. You can see the diagram here. There are four circles drawn as the same radius as the ball. Okay? And this thread which you are tied on the ball, open up the whole thread and try to cover this thread, this circle with the thread. And we will observe that the whole thread covers exactly four circles. So the radius we know was r. We have taken r and the area of a circle is pi r square. Now since there are 1, 2, 3 and 4 circles which cover the whole thread, the surface area of the sphere is 4 pi r square. Remember this formula, this is the practical work. If you want to do, you can. If you do not want, just remember the curved surface area of a sphere is 4 pi r square. Now what about the total surface area? If you look at the sphere, there are no flat surfaces. All you have is curved surface. So the total surface area of a sphere is also 4 pi r square. So the curved surface area and the total surface area of the sphere is the same. What about the hemisphere? Okay, a hemisphere is formed when we cut a sphere with a plane passing through the center. I told you. Yes, you take a smiley, a ball, and this is the center of the sphere. When this ball touch, the center touches each other. Now from this center, take a knife and cut off the smiley. This half ball that you get is a hemisphere. Now what is the curved surface of a hemisphere? The curved surface, the curved one here will be half of the sphere. So half into 4 pi r square the sphere, 1 the 2 the. So a hemisphere has got a curved surface area 2 pi r square. Let me write here 2 pi r square. And what is the total surface of the hemisphere? You can see apart from the curved surface, now there is a flat part also, which is the circle, whose area is pi r square. So total surface areas will be this 2 pi r square plus pi r square equal to 3 pi r square. We have got 3 pi r square. So is it clear to you? This is what we have. CSA is 2 pi r square, TSA is 3 pi r square. In the case of the sphere, they both were the one and the same, 4 pi r square. Now we start with the sums. Find the surface area. Curved or total makes no difference because it is a sphere of radius 7. So use the formula now. CSA of sphere. Have you remembered the formula? What is the formula? 4 pi r square. So 4 into 22 upon 7 into 7 into 7. 7 and 7 cut. 7 4s are 28. So 28 into 22. How much is that? Let's calculate. 616 centimeter square is the surface area of the sphere. This was a simple sum. Let us go to the next one. Find the curved surface area and total surface area of a hemisphere of radius 21. So let us begin. Curved surface area of hemisphere. Again, do you remember the formula? The curved surface area is 2 pi r square. So 2 into 22 upon 7 into r21 into r21. 7 ones are 7 threes are 22 twos are 44. 21 threes are 63. Multiply this, you will get your answer in the centimeter square. TSA of hemisphere. Again, note down the formula. What is the TSA? 3 pi r square equal to 3 into 22 by 7 into 21 into 21. 7 ones are 7 threes are. So 9 into 22 into 21. Multiply this. Get your answer is the total surface area of the hemisphere. Now we have a hollow sphere. What is a hollow sphere? Like a ball with empty space inside is a hollow sphere in which a circus motorcyclist performs a stunt as a diameter 7 meter. So diameter here is 7 meter. So radius is 7 upon 2 meter. Find the area available to the motorcyclist for riding. Since this is hollow from inside, we can say CSA or TSA. It makes no difference of sphere. What is the formula? 4 pi r square. So 4 into 22 by 7 into 7 upon 2 into 7 upon 2. 7 7 cut, 2 1 2 2 2 and 2 cut. So 22 into 7, 154 meter square is the area for the motorcyclist to do his stunts. Then we have a hemispherical dome. You can see in the figure the dome on the top. The hemispherical dome needs to be painted. Circumference of the base of the dome is 17.6 meters. So the circumference at the bottom of the dome is 17.6 meter and the cost of painting is rupees 5 per 100 centimeter square. We have to find the total cost. So we are not given the radius. Now we know, let us see, we have to paint the hemispheres. We have to find the CSA of hemisphere because bottom we are not painting. CSA of hemisphere. What is the formula of CSA of hemisphere? 2 pi r square. But where is the r? The r is not given. We are given the circumference of the base. So circumference of a circle. What is the formula for circumference of a circle? 2 pi r. Now circumference is given 17.6 meter equal to 2 into 22 by 7 into r. So what is r equal to? R equal to 176 upon 10 into 7 upon 2 into 22. Rearranging we get this. So 2 ones are 288 are 22 ones are 22 fours are 2 twos are 2 fives are. So 14 upon 5 is the radius. Okay. So now we have the radius. So let us put in the formula. So 2 into 22 by 7 into 14 upon 5 into 14 upon 5 meter square. You can see the sum is in meter, so it is meter square. Now the cost is how much? So let us first convert meter square into centimeter square. 1 meter square equal to 1 meter into 1 meter equal to 100 centimeter into 100 centimeter equal to 10,000 centimeter square. This will now become 2 into 22 upon 7 into 14 by 5 into 14 by 5 into 10,000 centimeter square. Now the cost of 100 centimeter square is 5 rupees. So 100 centimeter square is 5 rupees. So this much, this area CSA will be how much? CSA. You cross multiply, so CSA into 5 upon 100 to give us the answer. 0 0 0 0 cut, 5 5 cut, 5 ones are 5 20s are 7 ones are 7 twos are. So multiplying this remaining thing will give you your answer in the rupees. I am not doing the calculation for you. You can do the calculation on your own. So you can see here, once you remember the formulae, the sums become very simple. All you have to do is remember the formula thoroughly. So keep on revising the formulae. The next sum we have is the radius of a spherical balloon increases from 7 centimeter to 14 centimeter when air is pumped into it. So here we have got two radius. I'll call R1 radius 7 centimeter. I'll call R2 14 centimeter. Now we have to find the ratio of the surface area to the balloon in the two cases. So I'll say CSA 1 and CSA 2. I have to just find the ratios. So what is CSA 1? 2 pi R1 square. What is CSA 2? 2 pi R2 square. 2 and pi cancel. Okay, no, that's the balloon, so it will be 4 pi, sorry. 4 pi R1 square upon 4 pi R2, so it's a spherical balloon. So 4 pi. But 4 and pi will get cut. So the ratio is just R1 square upon R2 square. So 7 square upon 14 square is 7 into 7 upon 14 into 14. 7 1s are 7 2s are 1s are 2s are 1 upon 4. So the ratio of the surface area is 1 is to 4. So what you can see, when the radius becomes double, twice, 7 becomes 14, the surface area becomes 4 times. So this is very, very important. The radius becomes double, the area becomes 4 times. Now, we have a hemispherical bowl of brass. We will take a brass bowl. We'll draw a hemispherical bowl of brass having diameter 10.5 centimeter. So, diameter is 10.5 centimeter. I'll call 105 upon 10 centimeter. With the cutting, it will be how much? 21 upon 2. So 21 upon 2 centimeter, that is diameter. So radius will be 21 upon 4 because we have to multiply this by half. So 25 upon 4 centimeter is the radius. We have to tin plate it from the inside at the rate of 16 rupees per 100 centimeter square. Now when you tin plate, you will only tin plate the curved surface area from inside, not the top. You will not do on the top. So you have to find the curved surface area. What is the formula? Remember 2 pi r square. So 2 into 22 upon 7 into r square, 21 upon 4 into 21 upon 4. 7 ones are, 7 threes are, 2 ones are, 2 twos are, 2 ones are, 2 11. So this is the CSA. But now rate of 100 is 16. So what is the rate of CSA? The rate for 100 centimeter square is 16. So rate of the CSA will be how much? So we'll cross multiply. So 11 into 3 into 21 upon 4 into 16 upon 100. 4 ones are, 4 fours are. So do the multiplication. What do we get? 44 into 63. 63 into 44. 0, 2, 1, 25, 252, 2772. So 2772 upon 100 gives us how much rupees? 27.72 rupees. Yes? So very simple sums these are. If you know the formulae, you will easily get the answers. Now, the diameter of the moon is approximately 1/4 the diameter of the earth. So let us write. Diameter of the moon ratio is 1/4 the diameter of the earth. We have to find the ratio of the surface area. So, radius of the moon will be half. Yes, the ratio is 1 is to 4. So we have got dm is to de is 1 is to 4. If I divide the diameter by 2, I divide both of this by 2, then this will give me the ratio of the radius. But again 2 to cancel on both sides, I still get 1 is to 4. So the diameter is in the ratio 1:4, even the radius is in the same ratio 1 is to 4. So we did this kind of sum before. CSA 1 upon CSA 2 is 4 pi R1 square upon 4 pi R2 square. 4 pi 4 pi cut, so you got R1 square upon R2 square. Now what is the ratio R1 upon R2? R1 upon R2 we had got was also 1 upon 4. So this is 1 upon 4, the whole square gives us 1 upon 16. So the ratio of the surface area is 1 upon 16. So what you can see, when the radius becomes 4 times, the surface area becomes square of the 4 times, that is becomes 16 times. Now again we have here a hemispherical bowl is made of steel. Now this time we have got a bowl with a thickness. The thickness is 0.25 centimeter. So this thickness of the bowl, not the bowl, only the thickness is 0.25 centimeter. And the inner radius of the bowl is 5 centimeters. So the inner radius of the bowl, is 5 centimeter, 5, and the outer thickness is 0.25. We have to find the outer curved surface area of the bowl. Now outer CSA is nothing but 4, not sorry 4, this is 2, hemispherical, 2 pi r square, simple formula. We will write here O, the outer radius. So what is the outer radius? RO equal to inner radius RY, inner, plus the thickness T. So RI is 5 plus 0.25 gives us 5.25 centimeter. That is the outer thickness of the bowl. So the curved surface area will be 2 into 22 upon 7 into 5 to 5 upon 100 into 5 to 5 upon 100. So 7 ones are 7, 7s are 49, 35, 7 5s are 35. 25 3s are 25 4s are 2 1s are 2 2s are 2 1s are 2 11s are. So we'll have the answer 33 into 525 upon 100. So 525 to 33 is 0, 3, 5, 5, carry 1, 7, 5, 12, 13, 7, 1. So you've got 17325 upon 100, okay, or equal to 173.25 centimeter square. That is the curved surface area of the outer side of the bowl. Now the next sum we have is a good one. Now we are taking the sphere and the cylinder. So a right circular cylinder just encloses. What does just encloses mean? Just encloses mean when you put the cylinder inside, it is touching from all sides. You can see this sphere is touching the cylinder from all sides, just enclosing. So you have to find the surface area of the sphere, you have to find the curved surface area of the cylinder and the ratios obtained. Now there is no measurement, you only said it is having a radius r. So what you have to first find? Now you can see here, what is the radius of the cylinder? Is r. But that is also the radius of the sphere, r. Why r? Because the sphere is just touching it. Now this radius of the sphere is also r. So this much is r. Even the bottom radius is r. This is also r. So what you can understand here, the height of the cylinder will be 2r, or the diameter of the sphere. The diameter of the sphere is the height of the cylinder. So let us begin now. CSA of sphere is how much? 4 pi r square, and since it is r, we keep the formula as it is. CSA of cylinder is how much? 2 pi RH equal to 2 pi into R, and H is 2R. H is equal to 2R. So you have got 4 pi R square. So the ratios obtained: CSA of sphere upon CSA of cylinder equal to 4 pi r square upon 4 pi r square is equal to 1, or 1 upon 1. So the ratios are 1 is to 1. So the curved surface area of the cylinder and the sphere, when put inside, when both are the same, is in the ratio 1 is to 1. But you will see later now, the curved surface area is the same, but you can see very clearly the volumes are different. The cylinder occupies more space than the sphere. So now we have done the lesson so far till here. So just for the revision sake, I have made this chart for you. All you have to do is remember the formula well. If you remember the formula, then there is no issue at all and you will be able to do the sums. So the lateral surface of the cuboid was 2h L plus B. Total surface area of cuboid was 2LH plus BH plus LB. Now if you don't remember how we got the formula, you can go back and revise the previous lectures. The LSA, that is the lateral surface of cube, and TSA of cube, the CSA and TSA of a cylinder, the cone, the sphere and the hemisphere. So we have done 6 three-dimensional shapes till now, and we have learned the formula for the lateral or the curved surface area and the total surface area. So what have you understood? If you remember the formula well, then there is no issue, you will get the answers very easily. So I'm going to end the first part of the chapter here. This is the 4th lecture, right? And up to this lectures we have finished the curved surface area and the total surface area. Next we are going to move into the volumes. But that will be in the later chapter, later lectures. So I'm going to end here.